Hi everyone. In this video we are going to cover section 7.1, linear equations. And we start out by addressing how we create linear equations. First, kind of what do we need? Given two pieces of information, we can write a linear equation. We could either be given a point and a slope, a direction that we're going to move, or we can be given 2 points. That's what the initial information that we need in order to write our linear equation. The next piece I want to address is the different types of the different forms for our linear equations. And it's important, especially in my math lab, to kind of pay attention to what form they are looking for so you know how to enter your answer into the system. So we have what's called standard form. Standard form looks like ax plus by equals c. The variable terms are on the left-hand side, and the constant term is on the right-hand side. Then we have slope-intercept form. That's the one you're definitely familiar with from some algebra course in the past. Y equals mx plus b. It's called slope-intercept form. It's the most common way to see the equation of a line because it gives us useful information, namely the slope and the y-intercept. And then one you might be a little bit less familiar with is called point-slope form. This is a formula that we use when we're given a slope and a point. That makes substituting real easy because you just put the slope here and the point there, and you have what's called point-slope form, which you can distribute the slope and add the y-intercept, and then that'll put it into slope-intercept form. So three different kind of terms to be familiar with here. Hopefully a little bit of prior knowledge is coming back. Hopefully not to haunt you, but hopefully coming back to you. One skill that we need to have is changing from one form into another. So here we have the equation 6x plus 4y equals 12 up there, and it says to solve the equation for y. So what I want to do first is rewrite my equation down here. 6x plus 4y equals 12. That's standard form, to use a term from the previous slide. And if we need to solve it for y, we're first going to subtract the 6x on the left-hand side, subtract it on the right-hand side. I'm not going to write it right underneath the 12 because they're not like terms, so they don't combine together. Okay, on the left, the x's cancel out. Some of you like to put that, well, you don't do dotted. Some of you like to put that vertical line there. You can, you don't have to. I personally don't like to, so I'm going to leave it off. But I am going to drop down my 4y, and I'm going to drop down my 12 and my minus 6x, but I'm going to flip up the order there. I want to write the x term first, and note that it's negative, a negative 6x, and the 12 that's up top is positive, so negative 6x plus 12. And that should say 4y on the left, not 4x. That little typo there. That looks messy. 4y. There we go. Our last step, I'll stick with red now, is to divide everything through by 4. Okay, 4y, when you divide by 4, the 4's go away, leaving me with just a y. Negative 6x divided by 4. Now that's a fraction. It doesn't divide in evenly, but I can definitely reduce or simplify that fraction. Divide the numerator and the denominator by 2, and you have negative 3 halves x plus 12 divided by 4 is 3. So we have y equals negative 3 halves x plus 3. So that's one skill you got to have, being able to solve an equation given in any form for a specific variable. Okay, let's start out on this next slide. Looking up at the top, we'll kind of define a couple of terms here. We have a y-intercept. That's where the line crosses the y-axis, and at that point, x equals 0. So if I were to look at the coordinates of that point right there, it would be like 0, 1, 2, 3, 4, 5, 0, 5. And then the x-intercept over here is where y equals 0, and the line crosses the x-axis. So that would be something, 0. 1, 2, 3, 4, 5, 0. Okay, so two terms, y-intercept, x-intercept, right? We can identify them on the graph on the left also. Here my x-intercept is negative 2, and my y-intercept looks like it's about 6. I think it cleanly goes through that point. Okay, so just a couple of examples of graphs at the top, and then in the example that we have to answer, we are told to find the intercepts, the x and the y-intercepts, and then graph the equation. Okay, so to find the intercepts, what I like to do is to make a little table. Okay, so notice here the x coordinate was 0, so I'm going to put a 0 in my x column. Here, the y coordinate was 0 up top, so I'm going to put a 0 in my y column. All right? And so when x is equal to 0, now I'm looking at my equation. When x is equal to 0, that term drops out, right? I would have 3 times 0 plus 5y equals 20. 3 times 0 is 0. Divide both sides by 5, and we get y equals 4. That goes there. So 0, 4 is the y-intercept. Then when y is equal to 0, this term drops out, right? And it'll be pretty straightforward to solve for x. 3x plus 5 times 0 equals 20. 3x equals 20. Divide by 3, and I get not a nice whole number. 20 divided by 3. 3 goes in like 6 times with 2 left over. If you typed that into your calculator, it would say 6.6 repeating. Okay, so I'm just going to write it as a mixed number, 6 2/3. And it says graph the equation. So when you do your homework in my math lab, that'll have graphing tools that you will use and need to learn how to use. I, for the purposes of your notes, am just going to sketch a little graph here. And my scale, I need to go out to 4 in the y direction. So let's go up 4 and down 4. And I need to go out to 6 or 7 in the x direction. Something like that. So my y-intercept was over 0, up 4, puts me right there. And my x-intercept is over 6 2/3 and up nothing. 1, 2, 3, 4, 5, 6, and 2/3 looks to be about there. And then I draw a line through the dots, put arrows at the end, and I'm going to label my picture 3x plus 5y equals 20. Okay, again, this is just for your notes. My math lab has very stringent tools that you're going to learn how to use. Another word that I mentioned earlier, but we're going to get a clear definition here, is that of slope. We need to know the slope of our line, or the steepness of our line. That's important to drawing these models correctly and accurately. Roofers often, they need to know the slope or the pitch of a roof of a house, because if it's not correct, things can get pretty out of whack in terms of like cutting the wood at the right angles for the roof joists. I'm not sure if that's the right construction word. Roof girders? There's a word there. I'm not sure if I'm using the right one. But for slope, we have a couple of different ways to look at it. Slope is the rise over the run. That's kind of the sing-songy way to remember it. Rise means up and down. Run means left and right. The y rise is on top. It's the change in y over the change in x, right? The rise is the y's. Okay, and then as a formula, y2 minus y1 over x2 minus x1. You've seen these terms and formulas before, okay, but I'm putting it all out there for you. Okay, so when I count from this point to this point, I'm going to go up first, that's the rise, then count whatever the run is. If I'm given 2 points, as I am in this example, 1, 5, and 6, 45, I'm definitely going to use the formula being m equals y2 minus y1 over x2 minus x1. One thing that will help you in substituting into the formula correctly is I like to just go x, y above my points. Some people also like to put the subscripts on, so there's a couple of 1s, there's a couple of 2s. That's really going to just make it pretty simple to plug into the formula. I start with my y2. y2 is 45 minus y1 is 5 over x2 is 6 minus x1 is 1. Do my subtraction. 40 over 5 is 8. Also helpful to think of it as 8 over 1. My math lab is going to want you to put that in as an 8. 8 over 1, I like to, again, think of it that way because that tells me to rise 8 while I run 1. Okay, but 8 is the slope of the line that connects those 2 points. Talk briefly about a couple of specific slopes. That is a slope for a horizontal line. Horizontal line doesn't have any rise because it's horizontal. 0 divided by any number is equal to 0. So the slope of a horizontal line, always 0. Slope of a vertical line is what's called undefined. It is not defined because we have a run of 0, a rise of some number, a run of 0. Any number divided by 0 is undefined. If you're not sure whether you're dealing with a 0 slope or an undefined slope, just check. And you check in your calculator, right? Type into your calculator 0 divided by 4. Your calculator will spit out a 0. If you type 4 divided by 0 into your calculator, it will say some form of the word undefined, or it might say error, or it might say but it'll definitely clue you in as to which of these two cases you're looking at. Okay, in this example, we're just kind of given the information pretty directly, so not much work to do here. But when we have the equation y equals 2x plus 3, the slope is 2, right? That's why it's called slope-intercept form. Y equals mx plus b. And the y-intercept is 3. That's the intercept in slope-intercept form. So slope-intercept tells the order. The slope is the number in front of the x term, the number in front of the variable. The 3, the y-intercept, is the number that is by itself. So what's useful about that is if I have slope-intercept form, I can very quickly generate a graph of that line. Okay, I'm going to add on a decent scale here. 2, 3, 4, 1, 2, 3, 4, 5. A decent scale, not a spectacular scale. You start at the y-intercept over 0, up 3, and then we use the slope of 2, which equals 2 over 1, to rise 1, 2, and run 1. Rise 1, 2, and run 1. And I can go in the opposite direction, fall 1, 2, and run backwards 1. And wow, I kind of missed my points. Luckily, I have an undo button. That's much better. And we play connect the dots, draw a nice line through our points, adding arrows, and my equation. There we go. Let's do one more example where we graph a linear equation. So we're given y equals 3x plus 4. First, we need to identify the slope is the number in front of the x. That is the 3 right there. And when I write it down, I like to write it down as 3 over 1. But remember, my math lab will just want you to put it as a whole number, 3. And then my y-intercept is the number by itself. That is the 4 right there. Okay, those are the only two pieces of information that I need to graph this line. Okay, I'm going to do a nice little scale again. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Luckily, you won't have to do this by hand. 5, 6, 7, 8. In my math lab, they will give you a nice looking graph. 1, 2, 3, 4, 5, 6. I can't talk and do lines at the same time. They'll give you a nice graph to make this on. Just make sure that you take the time to learn how to use the graphing tool. Okay, so start here. It's called the y-intercept. This is my x-axis. This is my y-axis. 1, 2, 3, 4. Draw that point first. And if it helps to write that as 0, 4, go for it. Okay, but that's where we start. And then the slope, this tells me where to go. Go up 3 over 1. So from that first point, I'm going to rise 1, 2, 3, and run 1. I can do it again, 1, 2, 3. I'm going outside my scale. That's okay. Run 1. And I'm going to fall 1, 2, 3, and run backwards 1. We'll do one more point. 1, 2, 3. Run backwards 1. Okay, the scale got a little bit messed up. I don't know how straight this line is going to look. My scale could have been better, but it's just a sketch. Ooh, yeah, that last point definitely it missed. Okay, but hopefully you get the idea. Using the graphing tool, it'll be much more precise. Label my line, y equals 3x plus 4. Finally, we come to the last example of this first section. You can pause the video and read through the problem. I'm not going to read all of it for you. I'll just use my highlighter and highlight the important pieces. You got Plan A, $35 base fee, $12.50 per hour. So $12.50 once and then twice and then 3 times, depending on how long you rent your SUP board. Anybody wondering what that is? If you know what that is, it makes you really cool. It stands for Stand Up Paddleboard. Stand up paddleboarding, it's a pretty cool thing. If you can stand up paddleboard, I am already impressed by you. That's Plan A's cost. Plan B is $22.50 plus $15 an hour. So how do I write them as linear equations? Plan A. Okay, we're going to write Plan A and Plan B both as linear equations. Y equals mx plus b. And the way that this works, the $35 and the $15 that you get charged one time, that represents the y-intercepts, right? That's the starting point. You pay this set dollar amount no matter what. That's the y-intercept, okay? And then the $12.50 an hour or $22.50 an hour, that's the you pay it once, twice, depending on how long you rent the board for. That's the slope. That's the up $12.50 over 1 hour, up $12.50 over 1 hour, etc. So to write these linear equations, y equals 12.50 x plus $35 has a higher starting point but a lower hourly rate. And for Plan B, y equals $15 per hour plus $22.50, a lower starting cost, but a little bit more per hour. Okay, and then if we were to use graph paper, or I already have the answer kind of on here for you, we're graphing and estimating when Plan A is better than Plan B, right? Plan A is worse at the beginning, but if I have my stand-up paddleboard long enough because I'm cool and love to paddleboard for hours, well, eventually Plan A, the red line, becomes cheaper, and it looks like on the graph it's somewhere between hours 4 and 6. We can get that exact number by setting the two equations equal to each other, but this just asked for an estimate, and we've got our graph done for us so that we can pretty quickly make that estimate. Okay, that's the end of section 7.1. Work on the homework. Let me know if you have questions. Thank you for listening, and have a wonderful day.